Okay, boys and girls, we are now finally getting this rodeo on the road here. This is Prehistory A Traveler's Guide. I am your host, Greg Nuttman. With me today are Scott, Sam, and Chris. And joining us for the first time in this program is one of the world's most influential experts on all things Tyrannosaur, Dr. Philip J. Currie from the Royal Tyrrell Museum. Welcome aboard to the show, Dr. Currie.
Well, thank you for having me.
We've been wanting to have you on for a very long time. I did a poll a while back, and you got the majority of the vote, so hence you were my most sought-after guy to have on the program.
Well, that's pretty cool.
Yeah, and a special shout-out to the Facebook group Paleo World for helping to bring this together, and for coming up with some very, very good questions. One of the topic points will be that Tyrannosaurid and Tagamet chart that you helped put together along with Dr. Carr. And the one that Joshua Walsey worked on. He wanted to get some more information about something that was in that paper. We'll get to that. All right, Chris, you want to start off with your personal questions here?
Yes, I'll get started with this first one. What is it about theropods that interests you the most?
Well, I think part of it's the mystery surrounding them. This sounds a little contrite, but I mean, the thing is that theropods, generally speaking, are a lot rarer than the herbivores. And we also tend to not have as good a skeletal record for most theropods. I mean, there are certainly ones like Tyrannosaurus Rex and Albertosaurus and so on that we have many, many specimens that we can fall back on. But the more interesting theropods, of course, are the small ones. And the small ones are animals that are incredibly rare, almost everywhere. So there's a lot of mystery that we have to solve when we're dealing with the theropod dinosaurs. And I kind of like working with things where we have less to work with and have to find out more, I guess you would say.
Yeah, I can technically agree with that.
Aside from that, then, of course, theropods are also the animals that are still alive. And we can look at modern birds to get a better sense of what they probably were like. Everything from anatomy to behavior. And in a way that puts us in much better standing with theropods, too, in terms of what we can do.
Oh, all right, yeah, because me watching emus, chickens, I mean, I just watch those guys, how they move, basically. It just makes me get interested in how theropods behaved.
Exactly.
I think those are cassowary birds.
Yes. And I would say probably my second question would actually go towards about the zoo. And I'm kind of curious, why hasn't the zoo site haven't been given enough attraction about the idea that there was multiple skeletons in that same rock layer?
Well, I think it's got a lot to do with the fact that there's a little bit of confusion as to the identification of some of that material. I mean, there's no question that the second specimen, which is the hind leg of a slightly smaller individual, that's a Tyrannosaurus Rex. But then the really small material, some people believe it's Nanotyrannus as opposed to Tyrannosaurus, and other people, of course, believe it's Tyrannosaurus Rex. There's the old competition between the two ideas as to whether Nanotyrannus is a valid animal or not. And because you have a specimen that may not be Tyrannosaurus Rex in the same quarry as Sue, then of course that needs to be resolved, and it's not that easy to get back to that quarry and collect more material. But there's rumors out there certainly that some institutions would like to go back into the same quarry and extend the excavation and see if in fact there's more material.
Okay, because I'm thinking, I think the Field Museum did go out there, I think, one time, but I think they didn't find that much.
No, and I think the basic problem, though, is that there's a lot of overburden now on that quarry, and so reopen it and do it properly would be an awful lot of investment in time and money.
Mm-hmm. Yeah. Okay. Okay.
If I may, I actually want to run off one of my questions from Paleo World Corp member Kiefer Brown here. Let's talk about Nanotyrannosaurus. He asks, where do you stand in regards to the legitimacy of Nanotyrannosaurus lancensis as a either valid species or as a possible juvenile Tyrannosaurus Rex?
Well, I'm one of the people who believes that Nanotyrannosaurus is actually different than Tyrannosaurus Rex. I don't think it's necessarily a valid genus, because from what I can see, it's very closely related to Tyrannosaurus Rex as well. But I just don't buy the fact that you can have a juvenile specimen with as many more teeth as the Nanotyrannosaurus specimens have. And consequently, I believe that Nanotyrannosaurus probably is a valid species. But it's probably Tyrannosaurus lancensis versus Tyrannosaurus Rex. So the argument goes on, and I have certainly a strong interest in the whole question, but on the other hand, I don't think we can resolve it with the material that's out there right now necessarily, and I think we need to get a couple more specimens that are going to be analyzed for this.
And I think the best specimen to look at would be the dueling dinosaurs fossil. That might be the best evidence to determine to solve this question one way or another, but that's not even accessible to guys like you, last I heard.
No, it needs to get into a museum where, even if we do things on it, I mean, the trouble right now is we couldn't publish on it. And so for it to get into a museum first and then turn it loose with all of us guys looking at it, pick it apart, essentially.
Well, that's a very interesting answer you gave, Dr. Currie. So I think it's a fairly nuanced one. I mean, for myself personally, after I saw Dr. Holly Woodward's research at DinoFest and Bonustology, that line of evidence has me convinced that this is it's either juvenile T-Rex or possibly another subspecies or species of T-Rex.
Yeah, it is certainly a juvenile. I don't have any doubt about that myself. Not the type specimen, not Jane, not some of the other material that we've looked at. But the question is still, even if it's juvenile, there's no reason it has to be T-Rex. So.
Okay, Chris, I'll let you go. I'll let you go back to your set of questions you had then.
Okay. All right. I would actually say is there a particular clade or type of dinosaur family that you would like to study a little bit more?
I guess I tend to work more on the smaller theropods. So Velociraptorines. We have a beautiful specimen here in Alberta now that we collected a couple years ago that we're working on at the moment. Of course, troodontids I've always been interested in for many reasons. Their relationship to birds, their large brain size, the binocular vision, the fact that they have legs that are better adapted for running than just about anyone except for maybe a juvenile T-Rex, and so on. And these are those mysterious dinosaurs that I mentioned before, where we still don't have a complete specimen. I mean, the Troodon was found in 1854. Here we are a century and a half later, and we're still without a complete specimen from anywhere in North America. And granted, we've got good material now from Asia, so we can tell what the close relatives look like, but it still would be awfully nice for us to find one skeleton somewhere of a Troodon.
Yeah, that would be very interesting. Yeah, considering that complete skeletons are very rare.
Yeah.
For anything prehistoric, finding a complete skeleton is like hitting the jackpot. It just doesn't happen that often.
No. But it happens much more likely with bigger animals. And then in Asia, of course, you do have a preponderance of small animals that are well preserved too as complete skeletons. But that's the reason we've started working in Asia so much, is because of the fact that we could go and see complete skeletons of the animals that we had only bits and pieces of in North America. And so it was an important education, and got us to look at things in a different way and find a lot more evidence for a lot of these smaller animals.
Okay. All I think I will get to a question that I think I find particularly a set of interest of mine, and I think of yours. Is there a particular Tyrannosaur specimen that you think is the most fascinating to you?
Well, I guess slight prejudice here, and it's one of the specimens we found, and back in 1991, it's a Gorgosaurus from Dinosaur Provincial Park, and it's basically complete from the tip of the nose to the tip of the tail. It's a half-grown individual of Gorgosaurus, beautifully preserved, and I published on it back in 2003, but I still think there's a lot more work that can be done on that specimen. So it's on display at the Terrell Museum these days, so I have to get the glass taken off so I can look at it again, but I think that's one of the more fascinating ones for me. I think any one of the specimens that is reasonably complete is something that I always get fascinated by, because you think you know everything about these animals, but then when you start studying them closely, then you realize there's always something that you don't know anything about. And so tend to work on kind of obscure parts of the skeleton, like the brain case, for example. And we always find out something by it. The other animal that I've spent a lot of time on in recent years is Tarbosaurus from Mongolia. And we have a lot of specimens of Tarbosaurus. At last count, we identified more than 100 quarries of Tarbosaurus in Mongolia. Many of these quarries are, very sadly, ones that have been poached, and so we only get parts of the skeletons, because the poachers are very messy people. They tend not to collect the whole thing. They tend to destroy a lot of the specimen. But the wonderful thing about having 100 quarries you can rely on is you can look at the distribution of the specimens in both the geological context vertically, but you can also look at them from the geographic distribution aspect of it. And, we have certainly looked a lot at Albertosaurus here in Alberta in the context of an Albertosaurus bone bed that Barnum Brown had discovered back in 1910. And what it seems to say to us is that Albertosaurus is almost certainly a gregarious animal that travels in packs at certain times of the year. We kind of suspect the same is true for Tarbosaurus. It's a little harder to sort out with Tarbosaurus, because most Tarbosaurus specimens are found in one basin in Mongolia. It's about 150 kilometers wide, or roughly 110 miles or thereabouts, maybe 40 or 50 kilometers north-south. So it's a fairly big basin, but we get these concentrations of Tarbosaurus at certain levels, and I think it's very cool. We've got a lot of work to do on that yet, though.
Wow. Man, that Tarbosaurus quarries, man, I never knew that there were that many.
Yeah, it's staggering. And that doesn't account all the ones that have been collected previously where we don't have the information on where they're from in the Nemegt Basin. So the Russians collected quite a few, the Poles collected quite a few. We know where most of the Polish ones came from. And then other expeditions have collected specimens as well. But if we don't know where the quarry is, then that isn't part of that 100 specimen list that I mentioned.
Right. Greg, I'll let you get to your question.
Okay, this was actually one of your questions, Chris.
Okay, yeah. This, knowing about who is your mentor in your career.
Well, my mentor was probably Roy Chapman Andrews, I guess. Because when I was 11 years old, I read his book all about dinosaurs, and that's what made me decide the same day that I was going to be a dinosaur paleontologist. And of course, Roy Chapman Andrews was not a paleontologist at all. He was the expedition leader, but he wrote about it so eloquently. And in many ways, I guess I fashioned my career after his career. I was very interested in putting together large multidisciplinary expeditions, for example. So when Andrews led the expeditions to Central Asia back in the 1920s, he had ornithologists and geologists and botanists and paleontologists and so on. It was a multidisciplinary, multinational expedition. And it seemed to me that's the way to go. So when we started working in China with the Canada-China Dinosaur Project, we were a little bit more focused. We were focused on mostly dinosaurs, but on the expedition we had sedimentologists, we had people who were experts in fossil turtles or lizards or mammals, people who worked with invertebrate fossils and so on. So we could learn a lot about the paleoecology of the sites that were producing the dinosaurs in Central Asia, and learn something about what the environments represented, why they're so different in what they produce compared to the sites in North America. So also one of the reasons that I do write popular books and give popular lectures and so on. I really feel that's important, that as a scientist we make people in the public aware of what we're doing. First of all, because they're interested in it, but secondly, they have a right to know.
Okay, good. And I want to talk about about your Argentina expeditions. And I want to ask you about about all the discoveries that have been made in Argentina. Is it actually another great place to find more dinosaurs? Considering that we hear that there's more giant specimens being found, like mainly the sauropods, but all that sorts of stuff. Do you think that Argentina is a good place to actually find more dinosaurs?
Oh yeah, it's an amazing place actually, and I would say that if you look at where most dinosaurs are coming from these days, there's three real hot spots: the Gobi Desert of China and Mongolia, centered in that part of the world. There's the Western Interior Basin in the U.S. and Canada, and then there's Argentina, specifically right around Plaza Winkel in Patagonia, northern Patagonia. And basically, there are so many dinosaurs that are still to be found there. We still work there. We're still describing new dinosaurs, along with our colleagues like Rudolfo Coria. And, it's got a much deeper geological history than most places in North America. So you can't go to Alberta, for example, and see as much time represented as what we see in Argentina. And what that means is that we can basically decide that if we want to find some new dinosaurs, we can pick an age that doesn't have any dinosaurs represented, and we can go to that area, and almost certainly we're going to find dinosaurs. And the area we're working right now is the upper part of the early Cretaceous, or the lower part of the upper Cretaceous. We're not 100% sure. It's in that time interval, though. And basically, as predicted, we went there first about 10 years ago, and we're up to about 4 or 5 new types of dinosaurs in the last 10 years.
Wow, that's pretty cool. With all these dinosaurs, are they actually just differently compared to to the others that are compared to, do you guys find sauropods at all?
Yeah, we do, and I have to admit that I'm not a big fan of sauropods.
I understand.
Well,
I understand.
It's too much work to get them out. And
right. Yeah.
When we worked in China, we had found this specimen of Mamenchisaurus, and I was working on that for about a week. And it's a bizarre situation because, there you are in the middle of the Gobi Desert. There's no trees. There's very little to give you a sense of scale. And then one day I kind of looked at this rib I was working on from the neck. And this neck rib was about 10 to 12 feet long. And I realized that this is a hell of a big dinosaur. And I was going to be there for an awful long time if I was going to excavate the whole thing. So luckily for me, that was about the time that somebody else in the crew found Signraptor. And so I switched quarries and went and worked on Theropods, which was a much more manageable size. That's what I was interested in. And I've tried to avoid sauropods ever since. It's not that they're not interesting. They are extremely interesting, but they just are so big. Say the same.
Yeah, I was just about to say they just keep finding bigger and bigger ones every year, it seems.
Exactly. And it's the same with Tyrannosaurus Rex. I mean, we have 2 Canadian T-Rexes, and I've worked on all of them in different ways. But the one on display at the Terrell Museum is from just north of Drumheller. And that specimen was in fact found by C.M. Sternberg back in 1946. And he decided not to excavate it. The story goes that he didn't think it was complete and therefore not so interesting. But when we looked at it in the early 1980s, we realized that it was a pretty complete specimen. So we started to take it out. And when we took out the jacket with the hips and the hind legs, that jacket weighed 11 tons. And it was one of the biggest problems we ever had in terms of just even trying to prepare the things. We ended up putting something like 13 man-years of preparation into that specimen, just to get out of the rock. And then we had a second T-Rex at the same time, the one called Black Beauty, and it's the same story. It's a beautiful specimen, black bone and white rock. That's how it got its name. But the rock is incredibly hard, and it took us even longer, I think, to prepare that specimen. And the third specimen from this part of the world is Scotty, and Scotty's much bigger, in fact, than the other 2 specimens. There was about 20 years put into taking Scotty out of the rock in Saskatchewan and preparing all the bones on that animal. It's just a massive dinosaur, and unfortunately found in hard rock. So I definitely would prefer to find a Dromaeosaur or Troodontid over a big specimen of Tyrannosaurus Rex.
Yeah, definitely. I'm a Tyrannosaur fan, and it's my specialty. I've been reading Tyrannosaurs pretty much since I was like 5, and that's the reason why I love Tyrannosaurs so much.
Yep, same here. I've got a really awesome Dinosaurus T-Rex skull sitting in my bedroom. It's an absolute beauty in terms of quality. It's like a 3rd scale. It's a pretty decent sized skull.
Yeah.
I picked it up in Chicago.
Cool. I have a lot of Tyrannosaurus models in my collection.
I got a smaller scale stand skull in my room, and it's like almost like the actual thing. It's just that it's smaller scale and it was scanned and made it look like it was the actual thing. I'm impressed by the work by the Black Hills Institute of that. They did a really nice job of actually doing that.
Yeah, I have the same model, and it is very good in terms of trying to understand things. Sometimes I pull that model out just to take a look at it because I know it's scanned, and that helps a lot.
Yeah.
It's like we lost Greg.
Yeah, we lost Greg. Huh. Well, while Greg is trying to get back on, I'll ask you my marine reptile questions.
Sure.
That's okay with you. I read your volume that you edited about Dinosaur Provincial Park, and there was mention of riverine plesiosaur material found around the Red Deer River, apparently in association with freshwater animals like campsosaurs and soft-shelled turtles. And there was also a reference in there, too, about possible brackish water plioplatycarpine mosasaurs. Can you tell us about that material?
Yeah, it's, we're in an interesting situation. Dinosaur Park was definitely an inland environment, but not very far inland. We're talking perhaps 50 miles or so from the coastline at the time. And it appears that marine reptiles apparently would come up these big river systems. And some people think that they did it regularly, but I kind of think that probably they didn't do it that regularly. Otherwise, we'd find a lot more fossils of them. So it may have been that sometimes the small ones moved up the big streams to get away from, competing adults, we'll say, or animals that might chase them. And another thought is that maybe they were coming into the fresh water as a way to shed parasites that the freshwater invertebrates, the marine invertebrates would not. Although we don't have complete skeletons for any marine reptile out of Alberta, we have partial skeletons of quite a few marine reptiles now from the freshwater deposits of both Dinosaur Park and Drumheller. And in recent years, though, in the marine beds, the Bearpaw Formation, we have collected a lot of marine reptiles.
Would that include Nicholsaura?
Yes, it does. And so we have these marine reptiles are basically ranging in age from early Cretaceous right through to the latest Cretaceous. And beautiful specimens. Beautiful skulls on them, too.
Yeah, I've seen some of them. I have the papers.
Yeah, it's certainly not my specialty. There's people who do specialize in it, like Dawn Henderson. And, of course, Betsy Nichols, when she was alive, she specialized in marine reptiles as well.
I come across the name Tamaki Soto, too.
Yes. And Tamaki is a Japanese lady who, in fact, worked with us at the Terrell Museum at the University of Calgary for many years, and somebody we still have come over periodically to look at marine specimens.
Thank you.
You're welcome.
Should I begin with my first question now?
I gotta pull up Joshua Walsey's questions from Paleo World because he has some that specifically relate to your first question and more in depth. I'll read those off there, then I'll let you do yours then. Alright, give me 1 second. Alright, Joshua's question number 1 is he wants to know if the Tarbosaur thoracic skin imprint of specimen MPD 10760 from Mongolia was ever measured for its exact size. He estimated it was between 12 to 13 inches. Have you been able to examine that specimen in detail and given any exact measurement on that?
Okay, I have to ask which specimen again, because your voice cut out there at full point.
Alright, it's the picture that was featured in your book Dino Gangs of the Tarbosaur thoracic skin impression. Specimen number MPD 107-6A.
Yeah, I know the specimen, and in fact we do have other specimens now with skin impressions as well. So we're getting a better idea of what's going on with the skin of Tarbosaurus, but so far all of it is naked skin essentially. What we'd like to find, of course, is a specimen where we have skin covering most of the body so we can see if in fact these animals don't have feathers anywhere on their body, or perhaps they do have feathers somewhere on their body. Probably our best bet, though, is going to be in the Dragon's Tomb. The Dragon's Tomb is a site that was discovered by the Russians back in 1948, I guess it was. And this site has many, many skeletons of Sauropods in it, which are mummified. And in amongst those specimens are several Tarbosaurus skeletons as well. And so far we haven't seen, we've got a little bit of skin impression on one of the specimens, but not very much. But I have a feeling that if we ever reopen that site and extend the quarry, that we will find more Sauropods and also possibly more Tarbosaurus with skin.
Has that particular specimen actually been measured in detail?
No, again, this is another one of the specimens that sadly was poached before we saw it. So the specimen was in fact found a long time ago, back in the 1960s. And at that time, the Mongolian government decided they would protect the site rather than excavate all the specimens. And so that was one of the Tarbosaurs that was in situ in the field. But when we went there for the first time in the year 2000, we got there a little bit too late, and basically all of the skeletons had been poached in the intervening years since the last person had been there to see them. So it was a very, very sad occasion. So the skin was picked up, in fact, from the bottom of the quarry. They just either didn't recognize the fact that it was skin from the Tarbosaurus, or they didn't care.
And your specimen you're talking about is the one I just sent you in the picture, right?
I'm not seeing a picture, so
it's in the chat bar.
Okay.
Joshua provided me these pictures for this interview.
Yeah, let me see if I can just change the screen a little bit and see if I can get to see it.
It was the one featured in your book, Dino Gangs.
Yeah. Anyway, that would be the one.
That one got stolen, you said?
Yes.
Oh, that sucks.
Yeah, and how?
I'll let him know that's what happened to the specimen. That's why we don't have any exact measurements of it. He estimated it was between 12 to 13 inches total.
Yeah, that'd be about right.
Okay, alright. This next question also comes from Josh, and it also relates to Sam's question about Tyrannosaurus' thick skin and Tagamet.
And whether or not the skin was thick or whether it was thinner, I imagine that it's relatively thin compared to some of the other dinosaurs, and that's simply because of the fact that the tubercles or bumps on the skin itself are really quite small. And from what we can see in Tyrannosaurs, they all appear to have had this very, very small, bumpy skin texture to it. Usually that indicates a thinner type of skin than what we see on, say, Ceratopsian dinosaurs, certainly than Ankylosaurs. But until we actually get real skin, I mean skin where we can see the thickness of it, we can't be 100% sure of that. We're certainly looking all the time, and we're getting more and more of this all the time. We have skin now for basically all of the Tyrannosaurs, not just Tarbosaurus, but T-Rex, Albertosaurus, Gorgosaurus, Spletosaurus, and so on. Trouble is that they're all small patches of skin, and they really are just impressions around the skeleton itself. Still, we can always hold out and hope that at some point we are going to find some actual skin with some thickness to it and some structure to it, and that would give us a lot of information. And we're seeing that around the world we're starting to find these kind of things because we're looking for them, and so maybe eventually we will have some.
Okay, that's a pretty cool answer. And the question I had posted here was, what were your thoughts overall on the Tyrannosaur Tagamet regarding the Tyrannosaurus skin poster chart? Myself and others developed earlier this year with his input, and with your input, help of Dr. Carr, and he asks, do you think that more skin samples will show up in the future? There's also a similar question from our Kazarian, he asks, are there any specimens of skin preservations on Tyrannosaurs that have not been published or studied yet, and would you personally be interested in studying them?
Yeah, we produced another paper last year, actually, on skin this is Phil Bell and several other people, including myself, and I'm always interested in working on Tyrannosaur skin in particular because we have such few small patches of it. But we know that in certain sites in Mongolia, like the Dragon's Tomb, which I mentioned before, and in Alberta, where probably 25% of the dinosaurs we excavate from Dinosaur Park have skin somewhere on their body. We can hope that in the future we are going to get progressively more skin preserved on some of these specimens, and that will give us a lot more information on what's going on in the body. Yeah, so 100% I'm interested in it, and we're looking for it, and one day we're going to find more.
I hope you do, because there's I've seen a lot of nasty debates in the comment sections regarding, the feathered versus no feathers on Tyrannosaurs. And the paper that came out earlier this year that seemed to really skew heavily towards scales.
Yeah.
This is question number 4 from Joshua. It says, in the Bell Exceptional 2017 paper released this year on Tyrannosaur skin impressions, it was noted in the supplementary data that skin impressions from the holotype of Gorgosaurus were casted before being blasted over and may be in the Tyrrell collection. Also, in an interview with the persons, he revealed another skin sample from a Tyrannosaur not included in the paper, specimen TMB 2003.445.88. Will more data on these skin samples, including possible articulation, should come forward in the future and possible in other studies? There's also a follow-up similar one from Jeffrey Bond, also paleontologist. He wants to know, what are your thoughts on the various reactions to the Tyrannosaur and Tagamet study that you co-authored earlier this year? Did any of the reactions stick out in your mind, and what was your response to how it was received? Stuff like that.
A lot of people were interested in it, but it's kind of a funny thing these days where we don't get a lot of real questions necessarily about it. There's a lot of press interest in these things when they're released, and then very quickly fades from view, so we don't hear much. Now, it may well be that on some of the internet forums and so on that people are talking about it, but I don't necessarily see that because I really don't have the time to spend chasing these things, unfortunately. But they are brought to my attention, so there's no doubt that there's an interest there in it. I think that we will continue to study these specimens, but as usual, the way it works is that when we get a new specimen, something that can add more information, then we go back and we look at the old specimens again as well. And in the process of it, then we sometimes find new facts we didn't know before, and from that is generated yet another paper on dinosaur skin, particularly Tyrannosaur skin.
I hope we find a Tyrannosaur mummy someday, because that would definitely be the holy grail of opportunity that would solve so many of these questions and put an end to these debates in the Facebook comments sections that sometimes really get out of hand, almost uncivil.
What about the metabolism of these animals? Mesothermic, fully warm-blooded? What do you think?
I think they're fully warm-blooded. Let's face it, tyrannosaurs are animals that are related to all of the small feathered theropods. And so a long time ago, I guess around the year 2000, Michael Skrepnik, the paleo artist, did a piece of art for National Geographic, the children's magazine of National Geographic, actually. And I consulted on it, and basically what we decided to do was show a baby T-Rex hatching out of an egg. And it had feathers, but then the adult behind it had no feathers. And the reason this is relevant is because I think that everything points to the fact that Tyrannosaurs should have had feathers at some stage of their life, because we knew that closest relatives were all feathered animals. And of course we found Dilong and we found Utyrannus. There's no question that Tyrannosaurs that are primitive do have feathers. Okay, so why do the big guys not have feathers on them? Well, it's probably much the same thing that you don't find feathers or fur on whales and elephants today. I mean, basically, as you get big, it becomes more and more of a problem to get rid of excess body heat. Essentially, all you need to do is flex your muscles, and you produce enough heat because your surface area is so small compared to your volume. You don't lose the heat that fast. The last thing you need is any kind of insulation on the outside of your body. So I'm pretty sure that the reason we find feathers on these feathered dinosaurs is unequivocally to show that these in fact were warm-blooded animals, including tyrannosaurs, because they're part of that lineage. But the loss of feathers doesn't mean that they lost their warm-bloodedness. It just means that they're doing it in a slightly different way.
That makes sense. That makes sense to me. And actually, after having some thought about that new paper, I'm actually thinking Rex probably was more scaly than feathered. Though I won't dismiss it. It might have had some feathering on parts of its body, possibly.
Yeah.
Possibly.
I'm gonna ask my second question now. You guys basically just answered my first one.
Since it was relevant with other guys' questions that were more in detail, so I figured I'd combine them together.
All right. My second question is, how close are we to determining exactly what color dinosaurs were?
Well, that's so much fun right now. I think that's the hot spot for research. It's not just color, but the preservation of soft anatomy, and things like what Mary Schweitzer's doing, and people are doing with looking at melanosomes in feathers, melanosomes in skin. There's a lot of labs right now who are doing some pretty cool projects, and they're finding great results. I mean, we have bird feathers and dinosaur feathers inside of amber here in Alberta. It's not well preserved or as common as the stuff that's coming out there you see that the melanosomes are preserved and color patterns are also preserved. But it's also been found in skin. And the reality is that once you start that kind of research and you get as many labs involved in it as there are, then you start finding things out finally. Turns out that both melanosomes and soft anatomy are much more commonly preserved than we would have thought. Mary showed, of course, that this is true for a lot of the material from Montana, but in more recent years we've been doing the same kind of work here at the University of Alberta, and we're finding the same things that are being found down in Montana. Soft anatomy is not as rare as you think it would be, and if you look for it, sometimes you actually find it. So there's a lot of cool studies that are going on right now. We may never resolve all of the colors and be able to say what the whole spectrum of colors was in dinosaurs, but we are certainly finding out some of the colors, and we're finding out some of the color patterning as well.
Thank you. My next question is, do you think there are families or even whole suborders of dinosaurs that have yet to be discovered?
Absolutely, I do. We got off to an early start here in North America, and over a century and a half now, we've found a lot of dinosaurs, and to us, these are the normal dinosaurs. And so when the new finds are made in China or Mongolia or Argentina or Australia or whatever, those are weird-looking dinosaurs, but they're probably the common dinosaurs. It's our dinosaurs in North America that are really kind of the weird ones. They just happen to be the ones that we're most familiar with. And when you start looking at the discovery of animals like Therizinosaurus back in the 1980s and Daikaiju in the 1960s, now we know it's an even weirder animal than we would have thought originally. There's a lot of things out there that still have to be discovered. We have whole sections of the Earth where we have no dinosaurs preserved at this time. We have whole time periods when dinosaurs aren't known at all. And if I had to put my money on a bet, I would say that we probably know less than 1% of all the dinosaur species that actually lived. So we've thousands of dinosaurs yet to find. And almost certainly there's going to be some very weird types of dinosaurs that are not going to look anything like the ones we have right now.
And not anything like, should we say, conventional dinosaurs, the best way I can put it.
Correct. And, I don't know if you saw our paper a couple of years ago on Daikaiju, but of course that was an animal known from its giant arms in the 1960s. There was a lot of debate about it. And then we finally found a skeleton around 2008, 2009. In fact, we had two skeletons of it. And turned out to be an ornithomimid. So we put to rest the relationships of that dinosaur. But it's a bizarre ornithomimid. It's got a skull that looks like a duck-billed dinosaur. It's got feet that look like duck-billed dinosaurs. It's got spines on it like Spinosaurus. It's got these weird hands, of course. That's the only thing we did know about. But it's just a strange animal. And there's got to be a lot more like that out there. Therizinosaurus itself, of course, was known from those giant claws that the Russians initially thought were claws from a turtle. And these are meter or yard-long claws. And yet we still haven't found a complete skeleton of a Therizinosaurus from Mongolia. And you can bet that's going to be a bizarre animal when we find it.
Can I ask a question? What is the criteria, the dividing line, to decide where something is a theropod dinosaur or a bird? Or is there one? Or is it just,
Well, we're kind of spoiled these days in the sense that there's so much material that's come out in recent years that are between what we call a conventional bird and a conventional dinosaur. And so it's one of the best documented transitions that we have for any kinds of animals, going from non-avian dinosaurs into birds. And when the record gets that good, and we're looking at step-by-step progressions from one into the other group, then of course it starts to become arbitrary as where you put your emphasis on characters. For me, I'm one of the people who believes that Archaeopteryx was defined originally as the first bird, and that really arbitrarily Archaeopteryx should be the separation between birds and non-avian dinosaurs. And that's really what it comes down to. This is an arbitrary thing. Classification systems are a convenience that humans have invented so as a way to kind of organize things in our own minds. But whether you divide birds from dinosaurs on the basis of feathers or flight or the kind of warm-bloodedness that they have, or laying one egg rather than two, or whatever, I mean, those are arbitrary decisions. And we just have to pick the level that we want as the level that divides the two. And then there's going to be arguments still about all the ones that are close to the dividing line between the two as to whether or not they fall within the non-avian dinosaur side or the avian dinosaur side. The wonderful thing is that we're at that stage now where it's an arbitrary decision, and we're just trying to sort it all out based on that arbitrary decision of what the level was that divided the two. We're almost certainly going to end up with some dinosaurs that were actively flying. It's almost inevitable. There were so many lineages that appear to have been evolving rapidly and in sync with each other that flight may have evolved more than once. Certainly feathers and the long structures behind the arms, that probably evolved more than once as well. So this is a fun time for sure, because we have so many specimens that we can speculate on.
What they would call Mosaic Evolution.
Exactly. I think Mosaic Evolution is a very, very good term. It may or may not be real in the sense that all living birds today may have come from just one animal, if we go back in time far enough. But at the same time, there were a lot of other ones that were developing in tandem or evolving in tandem with that lineage, and certainly it adds to the confusion of trying to sort out the who's who and who's related to who.
Yeah, like the transition from fish to tetrapods. It's very gray.
Exactly, and of course we're still arguing about those things. We're still going out looking for new specimens. We're still getting surprised to find out that sometimes we tend to simplify things too much, and that the real story is a lot more complex.
Yep.
As I always like to say, truth is oftentimes stranger than fiction, or more disturbing than fiction.
Exactly.
My next question is, do you think there could have been species of tyrannosaurs that were even larger than Tyrannosaurus Rex, or do you think Tyrannosaurus Rex is pretty much as large as they got?
I think I would guess that Tyrannosaurus Rex is at the edge of what it can do as a bipedal animal. And the thing is that, of course, Spinosaurus may have been a bigger animal, but it may not have been bipedal. It may have been using water in the rivers, for example, to support its body weight. Certainly it seems to have had much shorter legs and was doing things in a different way. Wasn't relying on locomotion the same way that Tyrannosaurus Rex would. But if you're a large bipedal animal that's trying to run down your prey, Tyrannosaurus Rex is really getting to the extremes. That's why when we look at animals like Ceratosaurus or Giganotosaurus or Mammosaurus, they're all in about the same size range. And that doesn't mean that we won't eventually find something bigger. We might. Nature has this wonderful way of finding new ways to do things. And the only problem is that as you get bigger and bigger, then you have more and more of a weight problem to deal with. Tyrannosaurus has done some absolutely remarkable things to its skeleton that allowed it to get as big as it did. There's no saying that there weren't other kinds of adaptations that these animals couldn't have gone through and got a little bit bigger. But I think we're really pushing the limits right now for bipedal animals.
My last question for the time being is, do you think diseases played some role in the extinction of dinosaurs near the end of the Mesozoic?
Personally, I kind of doubt it. The reason for that is that animals are very adaptable. And so when you get a disease going through, there's almost invariably some animals that are genetically better fit to survive a particular disease. And those ones don't get killed by the disease. And when they don't get killed by the disease, it means they can spring back. And so species of animals, it's pretty rare to wipe out a whole species. There's almost invariably some animals within the population that will survive. And if they survive, then they bear the right genes that allows them to regenerate and recover. And that's for a single species, but if you're talking about a whole ecosystem and populations of many species of dinosaurs, I think the chances of any disease wiping them out would be very rare and unlikely.
Very much.
Okay, now I'm going to shift things over to one of the big topics of this interview, and that is the social behavior of Tyrannosaurs. We got a lot of very good questions asking you about this, so I'm going to try to hunt them down here and try to get them all compiled here. Hang with me here. And most of these questions stem from dino gangs.
Yeah.
Alright, this is the next question from... I'll just get all the questions and I'll read off the one that's the most detailed. This is the first question about them from Joshua Walsey. He asks, in your chapter on Tarbosaur brains and dino gangs, he asks, what are your thoughts on Tyrannosaurian intellect and brain function? And does this translate into complex hunting behavior patterns or the content of a social Tyrannosaur with social groups and pack hunter behavior? And another question about this also comes from Arson. He says, how much do we know, if at all really, about the social structure or relationship of the late Cretaceous Tyrannosaurs? And is there any update on the theory that you proposed in dino gangs that can give more insight into the matter? Is it possible that different species of the family may have had a different social structure? And lastly, which model of social behavior would you personally favor in this group? Solitary wanderers, family groups, or temporary mobs during migrations of the herds?
Yeah, maybe I'll work my way backwards through that because there is some logic to that too. And, I guess initially, like everybody, because of all those wonderful reconstructions of dinosaurs by Charles Knight and all the people who were doing them in science fiction, like Frank Frazetta and so on, they always tended to show dinosaurs, particularly Tyrannosaurs, as being animals who were moving as solitary hunters. Much to my surprise, though, when I started working in Alberta, then I realized fairly quickly that Barnum Brown had found a site back in 1910 where he felt there was a great number of Albertosaurus specimens in the same quarry and virtually no herbivores. And that really didn't make an awful lot of sense. And over the years, I kind of looked for the site, but we really didn't have much information. But in 1996, when I was at the American Museum of Natural History, I realized that when I looked at the material that Brown had collected, I realized that he had in fact not collected the whole bone bed. He had been high grading, and that as a consequence of that, there had to be still more specimens at the original site. So we launched an expedition to try and re-find the site. I had all of the archival material from the American Museum of Natural History to help me, including, luckily, one photograph that showed Peter Kaizen, his technician, sitting in the quarry. And we eventually re-found the site in 1997 and realized that our guess from the material in the American Museum was correct. That in fact Barnum Brown had been high grading. He'd only been taking certain parts of the skeleton because he was interested in the nose count. He wanted to know how many tyrannosaurs were coming out of the quarry. Basically, he found parts reports of 9 skeletons of Albertosaurus in the same place. So we reopened the quarry, and by the time we were finished the quarry, 13 years later, we had increased the number of Tyrannosaurs up to a minimum of about 20. And what that says loud and clear is this is a very unusual circumstance for many, many reasons. And that the only logical way to interpret it is that the Albertosaurus was in fact living in packs, because at the time that they died, they were together as a group, and they must have been doing that right up to the time that they died. And the quarry is just pretty amazing, because it does have remains of some other dinosaurs and other animals mixed in with the Albertosaurus bones, but they're an absolute minimum number of specimens. So probably less than 10% of all the other dinosaurs and all the other animals found in that quarry are in fact not Albertosaurus, but that's less than 10%, and considerably less than 10% as well. So something was definitely going on there, and so then it changed my thinking about it, and I started thinking in terms of these things moving in packs. Now, it makes perfect sense that they would do this at times. Not all the time, but just at certain times. And we have here in Alberta herds of duck-billed dinosaurs and herds of ceratopsian dinosaurs. And some of those herds where we have bone beds preserving individuals, we have as many as probably 10,000 individuals in one of these herds of duck-billed or ceratopsian dinosaurs. And Jack Horner, of course, is finding the same thing down in Montana. These duck-billed dinosaurs and horned dinosaurs and also ankylosaurs, we have evidence for that. These animals were moving in groups as well over in Asia. So dinosaur herbivores were moving like this. Why are they moving like this? Well, they're probably migrating through. There's arguments as to whether they're migrating north-south or east-west, but one thing we do know is that you can't take a herd of 10,000 Centrosaurus or another dinosaur which has a body weight of up to 4 tons. You can't take 10,000 of those animals and stick them into one area for any period of time. They had to have been moving through, going from one place to another. And one reason that animals herd together today, big animals, is because they are moving from one region to another because of food resources. And when that happens, they're also moving as a group as a way to protect themselves against carnivores. So when you get big herds of plant-eating animals, whether it's in the Cretaceous or now, you invariably end up forcing the carnivores to also be grouping animals. So if you look at the African veld, for example, where you get the big herds of wildebeest and other types of antelope and zebras and things like that, then you get prides of lions. It doesn't mean that all carnivores are packing animals, but you have packs of hyenas, you have packs of lions, you have packs of wild dogs, and then you have the solitary hunters as well, leopards, cheetahs, and so on. So you get this mix of things, but you do get a certain percentage of the carnivores being packing animals. Same thing happens in northern Canada when it comes to caribou and wolves, for example. Same thing was probably happening as well when the bison occupied most of the central part of North America. You had packs of wolves as well. So there is this association between herding in herbivores and packing in carnivores. So I'm pretty sure that the Albertosaurus bone bed we have here in Alberta is a result of these animals, in fact, collecting together when big herds of herbivores, both duck-billed dinosaurs and horned dinosaurs, were moving through the region. And at that time, the carnivores would get together into groups so that they could, in fact, break up the herds enough so they could get enough food to sustain themselves. It's not enough just for them to follow behind the herd, hoping things are going to die and that they're going to eat. They wouldn't get enough food that way. A pretty compelling idea, I think, and as time goes on, we're finding more and more evidence to show that herbivores are, in fact, animals at least occasionally grouped together for the purpose of hunting. The Mappasaurus quarry worked down in Argentina. We had 9 individuals in that quarry, not a single bone of another dinosaur. No herbivores whatsoever, although we did have sauropod footprints in the quarry. Certainly suggesting that Mappasaurus was another dinosaur that had gregarious behavior. We have another bone bed in Montana of Daspletosaurus, where again we have evidence to suggest that Daspletosaurus was an animal that probably occasionally packed. And there is some evidence as well to suggest that the quarry that produced Sue the Tyrannosaur may have had multiple individuals in it, and that in fact Sue may have been part of a larger group of Tyrannosaurus Rex. Did all herbivores, did all carnivores pack? No. It's just like lions versus leopards versus cheetahs. Certain species did it, other species did not, and in all certainty, these packs of animals were only for certain parts of the years, such as when the big herds were migrating through of the plant-eating dinosaurs.
That makes absolutely perfect sense when you use a real analogy like the African Serengeti and prehistoric Canada circa 75 million years ago. That makes perfect sense to me for them being solitary part of the year. Then when there's a big enough food source, then they actually become more cooperative to take advantage of the food source.
I wonder if that has anything to do with why humans are social creatures.
It might have something to do with it, but then again, there are a lot of other reasons that animals group together as social groups. Certainly in the herbivores case, they group together because when they're moving from one area to another, first of all, they have to move between those areas, and it's good to protect the young by having a lot of adults around. And the more adults there are, the better they are at protecting the young. Sometimes in terms of just the structure of the herd itself. I mean, musk oxen are a wonderful example of that, where the adults will in fact form a ring around the babies to keep wolves at bay. And that's kind of one extreme of what's probably going on a larger scale with all these other herding herbivores today. But as far as humans go, maybe there was a lot to that too, that they were more protecting their young and they could do it better as a social.
That's just simplifying things. And also relating to social behavior is parental care in Tyrannosaurs. There's some other questions about that. What are your beliefs on T-Rex parental care? And related to this is, considering the possibility of packing Tyrannosaurs, do you expect their young to be precocial or altricial?
Well, they're definitely precocial in a way. When you look at a young Tyrannosaur, it's absolutely amazing because these animals don't look like the adults. They're lightly built. They have very, very long legs. The proportions on the legs say that these are very fast-running animals. People often think that ostrich-mimic dinosaurs were the fastest dinosaurs, but when you look at the body proportions of a baby Tyrannosaur, they're even better for running than an ostrich-mimic dinosaur. These animals were really, really quick animals. And basically, I think that's in part because they had to keep up with their parents, and having the long legs and the ability to run fast certainly allowed them to do that. But it may have also been an adaptation that allowed these animals to, in fact, go hunt their own food when they had to, or when they were dealing with these big herds of animals, in fact, to move quickly through the herds and maybe scare something out of the herds of the parents. So there's all kinds of fun things you can do with the idea of gregarious dinosaurs and how the young looked next to the adults and so on. What it does suggest to me, though, is the fact that in the Albertosaurus bone bed, we had animals that ranged in size from about 2 meters long or 2 yards long, all the way up to almost 11 meters long, 11 yards. To have such a disparity in size from the youngest to the oldest, youngest we know from looking at bone histology was only about 2 years old. The oldest one was about 24 years old. And so these animals were together in the same group that we found in the bone bed. And that certainly suggests there's a level, at least, of parental care. They may not have been the nicest parents in the world, but nevertheless, they were protecting their young.
That makes sense. That makes sense to me. Do you think Tyrannosaur parents would have actually taken the extra 9 years and actually taught their young how to hunt, things like that, when they came of age?
I think by example they certainly did. But it also seems to me that there's a certain amount of, I don't know what you would call it, adaptation, which allows the young to do different things than the adults as well. There's no question that when you look at the young, they are much faster, more maneuverable, much more agile animals than the adults. And they're built very differently. They just don't have the same kind of powerful bite as the adults. So, they, I think, were in fact traveling with the adults, and they were using their example of the adults, but they were also doing something different than the adults, quite clearly.
Okay, this is the last question from Kiefer Brown. He asks, are you a proponent of the idea that Tyrannosaurs had high levels of plasma in their blood, allowing them to ward off infections similar to modern-day crocodilians?
Well, I would have to say I just don't know. And I don't see anything wrong with the idea. They certainly were aggressive animals. They certainly fought amongst each other. We have tooth marks on most skulls of Tyrannosaurs, showing that they did have these non-lethal interactions with each other where they were biting each other on the face. Some of those became infected. They recovered from them. We even have a broken tooth in one case inside the jaw of another Tyrannosaur where it healed up. So there was no question the tooth broke off and it healed up inside the bone of a second individual. So they were fighting with each other. And of course, being a carnivore is a tough life anyway. So if you're chasing down a duck-billed dinosaur or a ceratopsian dinosaur, you're going to get hurt at some point. And these animals probably did everything they could to survive these encounters and problems, and maybe they did it the same way crocodiles do, in terms of trying to avoid infections. But we really don't know. That's an area of I think future research as we get better with our tools and techniques and questions.
That makes sense to me. I actually remember recalling that another specimen of T-Rex that actually had a tooth embedded in like its brain case or something like that.
Yeah, there's one certainly that show. Well, in fact, there's several that show that they took bites to the head, which malformed the bones. So they have what looked like tooth marks that subsequently did become infected. The animal survived it, but marks are there.
Isn't that the same thing with the compound fracture from the Gorgosaurus specimen that is in the Indianapolis Children's Museum? Because it has that horrific broken leg and it healed over. I would think that would actually have to cause infection if it was poking through the skin.
Oh, absolutely. And there are many broken bones in Tyrannosaurs. Broken ribs, broken leg bones, usually just the fibula, because the fibula is a bone that's non-essential, I guess, for the support of the animal. But everything indicates that they were broken, rehealed, probably infected, and some nasty injuries. And of course, the speculation has been there that how do you sustain such nasty injuries and then survive unless somebody else is bringing you food? Well, that's possible, but we don't really know. But it's another line of evidence to suggest that they were gregarians.
And that they had a decent little healing factor to let them recover from injuries.
Yes.
I mean, that's just saying modern reptiles are very extraordinary in the ability to recover and sustain injuries that would be otherwise fatal to mammals.
Yeah, exactly.
I mean, gators and crocs, I've seen pictures of them with their legs bitten off in fights with other males during territory, and they're still able to survive from heinous injuries like that. It's absolutely astounding.
Yeah, there's one picture of one crocodile and his snout bitten off, more or less. So not too many teeth left, but it still survived.
Ouch.
I've Velociraptors. I've seen pictures of crocodiles with one of their eyes torn out in a fight with another crocodile.
You know, there's an author, I can't remember his name off the top of my head, published a paper a few years ago saying that he thought that crocodilians are secondarily cold-blooded and that they were evolved from a warm-blooded ancestor. Do you have any ideas about that claim? Or?
Well, I think it's distinctly possible. And part of the reason for that, of course, is that when you look at the animals that crocs are related to, we now know that dinosaurs, at least the theropod dinosaurs, were warm-blooded animals. We also have evidence that the pterosaurs were warm-blooded animals. And if pterosaurs, which are sort of the cousins to crocodiles, are warm-blooded, and dinosaurs, which are another cousin, but they're on both sides of the phylogeny with crocodiles in between. These are both warm-blooded. Why shouldn't crocodiles be warm-blooded, at least primitively? And so it's quite possible that the early crocodiles, as Jurassic and so on, were animals that were warm-blooded too.
Well, I know there was some primitive crocodilians that were bipedal.
Yes.
So
and,
that's interesting.
Even speculation that some of them were up in the trees, they were so agile.
Oh, they climb trees now. I've got a paper on that somewhere. Yeah.
Cool.
Even as far back as even as recent as the Pleistocene, there were some crocodiles that some believe actually were capable of living in the trees. They weren't very big, but they were able to climb trees.
So if they have become secondarily cold-blooded, this would be something along the lines of what has happened to the naked mole rat. It's a mammal, but it's technically cold-blooded, as I understand it. So,
and tree sloths as well.
Yeah.
Technically cold-blooded too.
Yeah, there must be some adaptive. There must be some adaptive reason for this. I don't know what it might be, but
probably trying to figure that out would be a lot easier than just wrapping your mind around the idea that animals can be adaptable to just about anything. And you get warm-blooded spiders and you get cold-blooded mammals, and so why shouldn't dinosaurs do what they wanted to do?
True.
Cold-blooded mammals. I never thought that was even a
Yeah,
thing.
the naked mole rat is technically, and I didn't know about the tree sloths were cold-blooded too. I know they're very sluggish, but
there's a species of goat that is actually found on an island, and it's actually cold-blooded.
About a year or two ago, they found a species of fish that's warm-blooded.
Well, I think tunas and some sharks as well are warm-blooded.
Yeah, mackerel sharks are pretty much considered to be the de facto warm-blooded sharks. Sharks like great whites and makos, porbeagles, and all members of the Lambdae group are described as being warm-blooded.
leatherback turtles.
What about leatherback turtles?
They're partially warm-blooded.
Yeah, they do it a little bit differently though, and that's probably like many dinosaurs, and why a lot of dinosaurs wouldn't have to be warm-blooded just by their size.
Yeah.
They have the stability of temperature inside their body, which is what you need, really, and under the right environments and so on. It's a much less expensive way, metabolically, to be a cold-blooded animal than it is to be a warm-blooded animal.
Yeah.
So if the cost of keeping your metabolism going is too high under the circumstances you're living under, why not become cold-blooded?
Sure.
Okay, Sam, I'll let you ask your question. You just came up with regarding the creature known as Smock.
Smock?
Like Smaug the dragon from The Hobbit.
Oh, yeah.
What are your views on the debate as to whether or not Smock was a theropod dinosaur or possibly a Rhysuchid? I think that's how it's pronounced. I kind of butcher that sometimes.
Well, there's always the possibility that these things happen, that these animals can survive. The big problem is always population size of the animal, what it takes to sustain a population in a certain area, and so on and so on. So I think we can always be hopeful that it's a theropod dinosaur,
Take a while to heat
have
it
to be a
up.
theropod dinosaur specialist,
cleaned it
or
out.
Velociraptors or whatever. All of that would be cool, but a I'd really like to see one of my hot little hands before I believed it.
Sorry, I just thought of one other question. What are your views on the possibility that had pterosaurs not gone extinct, some of them would have eventually have become flightless? What are your views on that theory?
Well, pterosaurs are so well adapted to flying, it just seems highly unlikely to me that they're going to follow that particular route. Anything is possible. Of course, nature does incredible things. And when you look at all the number of flightless birds on islands and so on, there's no reason to think that pterosaurs didn't do the same kind of thing, colonizing islands, let's say, and that food sources may have been good enough that they didn't have to actually fly around, and that they could actually shed the expensive problem of flying by becoming ground animals because of the fact that they had no competition anyway. So it wouldn't surprise me if eventually we did find flightless pterosaurs, or the skeletons of flightless pterosaurs. But so far I don't think we've had much evidence to suggest that we have those.
It certainly would be fascinating, though, if there were flightless pterosaurs.
Oh, yeah, yeah. And, there are things that we can look at that happen today. So, for example, when you get island populations of mammals, you always get a reduction in size. So there are many places in the world where we have fossil evidence of dwarf elephants. And, of course, now in southern Europe, we're finding a system of islands which had dinosaurs on them. And what are we finding? We're finding dwarf sauropods. So that's pretty cool.
There's also the other phenomenon where things that were small in the mainland grow larger on islands because they don't have predators to deal with anymore.
Yeah, exactly. Well, of course, is a great example. Or elephant birds.
Yep, that's a big example.
So maybe King Kong is not as improbable as some people think.
Yeah, we just got to find the right islands.
Before we started recording the program, I spoke to you about the controversy of Paleocene dinosaurs at Hell Creek, and you spoke on that. Would you expand on that since we're recording?
Yeah, well, let's look at the broader aspect of it first, and that when we're dealing with dinosaur extinction theories and so on, I think most of us accept that at the end of the Cretaceous, something really major happened, and it was probably related to an extraterrestrial boli hitting the Earth and causing major climatic changes and everything. The bottom line is that dinosaurs were so diverse at the end of the Cretaceous, and it's hard to believe that all dinosaurs became extinct everywhere in the world at the same time. No matter how nasty that event may have been, you still have small dinosaurs that were probably warm-blooded, that were covered with feathers, that were eating mammals, and mammals survived. There's food source there still, so they may have been stressed, but why would they become extinct at exactly the same time? Almost all of our record of the end of the Cretaceous comes from Western North America, and basically we're building models on dinosaur extinction happening everywhere in the world at the same time, but it's only based on one area of the world. Yeah, we have Cretaceous tertiary evidence in a few other places in the world, but most of them don't have dinosaurs, and they don't have a good record at the end of the Cretaceous either. So it wouldn't surprise me that eventually we're going to find a place where there was a refugium of dinosaurs, where some dinosaurs did manage to survive the Cretaceous. Maybe they didn't live far into the Paleocene, but maybe they did. So, having said that, and indicated what my prejudices are, I can't see there's anything wrong with the idea that there may, in fact, be Paleocene dinosaurs turning up in New Mexico or in other parts of the world. The problem is going to be not finding specimens, because we even have dinosaur footprints in Pleistocene beds in Alberta. The gigantic slabs of rock that were moved by glaciers and dumped there.
Reworking.
Yeah, the point is that you can get dinosaur bones reworked, you even get dinosaur footprints reworked, dinosaur eggshell reworked, and it ends up being in the younger beds. But what you need is absolute proof that those animals were living in the Paleocene or living in even younger times to convince everybody that this is a reality. I don't think anybody has a problem with, okay, maybe one day we are going to find dinosaurs that survived the Cretaceous Tertiary event. But you really need very, very strong proof.
More than teeth.
Yep. Say again?
More than teeth.
Yes, more than teeth.
Articulated specimens.
There are some very big dinosaur bones that have also been found, and they seem like they're too big to have been reworked. And there is some evidence from China that looks like it could be above the Cretaceous Tertiary boundary, and these are footprints and nests of eggs. That would certainly be pretty convincing as well. The trouble is that the boundary isn't that well marked in that area. There's some work being done, certainly for a long time down into Mexico, but one of the professors here at the University of Alberta has also been helping with that and looking at ways of aging the bones of dinosaurs that were found as Paleocene beds, showing that they're from the Paleocene and not from the Cretaceous. So there's certainly research going on these kind of things, and all of us are watching with great interest. But like I said, I wouldn't be tremendously surprised to find that somewhere in the world there were survivors.
Well, I know one tool that they're using now is rare earth element signature testing.
Yes, and some of that work is actually being done here at the University of Alberta. So
great.
It's pretty cool stuff.
Absolutely.
Sure. Might find the way.
Yep.
Yep. Quoting Dr. Ian Malcolm, aren't we?
Yeah.
Okay. Now I've got a good set of questions here from Arson's company here. Okay, his first actual question was, will we get a detailed study in comparison of Tyrannosaur teeth, including their shapes and sizes?
Well, there are a lot of people who work on Tyrannosaur teeth, including many of my students, and it's an area that is actually, it's surprising just how much you can look at a tooth. You know, you think that a Tyrannosaur tooth is a pretty simple structure, and but then when you get into it, you realize just how complex they are and how well adapted they were for that particular animal, and how much you can learn by studying them. So we're looking at everything from isotopes to just microscopic structure inside the denticles on the back and the front of the teeth, and learning more and more about Tyrannosaur teeth. They're very, very things. And luckily we have lots of specimens, and consequently we can do a lot of research, including destructive research, in terms of looking at these things.
That's very good to hear. Very good to hear. All right, next question from Arson Kasarian is there any way we will ever get a more detailed study on the specimen sizes of Tarbosaurus? Are the current given size estimates and reconstructions accurate, given the good skeletal drawings of Tarbosaurus are hard to find?
Yeah, well, the big problem with Tarbosaurus is that it's an abundance of riches. As I mentioned a little bit earlier, we've now found more than 100 quarries in Mongolia where we have Tarbosaurus specimens. And there are at least 30 or 40 skeletons that are very well preserved specimens. They go all the way from small animals that are only a couple meters long, big animals that are 11, maybe even 12 meters long. This abundance of material has been one of the problems with describing Tarbosaurus, and then trying to sort out whether in fact there are it's just one species or multiple species. But because the majority of specimens do come from one particular place, one particular level, so we have one very small geographic area and one very limited geological section where all these Tarbosaurus specimens come from. The odds are pretty good that we're only dealing with one species of Tarbosaurus, and that eventually we're going to have a pretty good understanding of the growth and variation of Tarbosaurus, because there are so many specimens and so many of them are so well preserved. But it's ongoing work, and in spite of the fact that the dinosaur has been known since 1946, the work still not done.
Of course. Just being realize about the Ankylosaurus. I mean, they just did a new paper about this creature, realizing that we really don't know that much about this type of dinosaur, even though it's been well known for almost 100+ years now.
Yeah. And, think about...
There's only like 3... go ahead.
Yeah, think about Tyrannosaurus Rex. I mean, the first description of that animal was 1905. But we still have a lot of questions about Tyrannosaurus Rex. And it's still one of the animals we ask the most questions about because of the fact we haven't solved a lot of these things yet. And there are a lot of people working on it now, but for a long time in the history of Tyrannosaurus Rex, nobody was working on Tyrannosaurus Rex. Tarbosaurus is the same problem.
Yep. And some of those other Tyrannosaurs that are even more obscure, like Studying Tyrannosaurs. I don't know of anyone that's specifically working on that particular genus.
Oh, no, and of course most of them are based only on single specimens or single partial skeletons. So they may be observed, but you need more than one specimen very often to try and understand the biology of the animal too.
Yeah, that absolutely, that is the case. And some dinosaurs like Allosaurus, we know a fairly decent amount about because we found so many different specimens from age groups and across the country and even across continents, and many specimens that have specific pathologies on them that give us even more insight into their behavior.
Yeah, and yeah, we still have questions with Allosaurus too. The Cleveland Lloyd Quarry is an incredibly cool place and produced thousands of specimens of Allosaurus, but it's mixed with the other dinosaurs, including things like Ceratosaurus and Tarbosaurus. Means that the picture is a little bit confusing sometimes, and what was going on with the Allosaurus specimens there may not have been the same as with the other carnivorous dinosaurs, let alone having all the herbivores in the same work. So there's still work to be done on Allosaurus as well.
I'll get back to that sometime after. I'll get back to that later on in the broadcast. All right, the next question here is. Next question is there any particular theory regarding why there has not been any Tyrannosaurus Rex specimens discovered in Alaska?
Well, it might be that T-Rex was too big of an animal to move that far north, but it may also be that we're just sampling the wrong beds. Alaska is, of course, an opening up area, and basically as more work gets put into Alaska, we find more sites, we find more geological levels. It wouldn't surprise me either that Tyrannosaurus Rex turns up there too. But right now, of course, there's relatively few specimens still that have been excavated in Alaska. And certain bone beds, of course, like the Liscum bone bed, they produce a lot of material, but it's a lot of the same kind of material over and over and over again. So we need more sites and better geological, level or geological age sampling in Alaska, and that's going to come with time.
Okay, I think that's a fair enough answer. Fair enough. All right, the next one is about a hadrosaur. With the discovery of the Japanese hadrosaur Mukowaryu, is there a chance that ecosystem could potentially mirror the North American one or the one from Asia, given that hadrosaurs were extremely common worldwide during the Cretaceous period?
About 15 minutes, so it doesn't get
the Japanese material is really exciting, for sure. But you have to recognize, too, the fact that I'm pretty sure that specimen is one that was washed out to sea. So the land would have been a little ways away, and we're not going to find a lot of specimens in those beds. The Japanese records is hard to evaluate in the sense that it's a terrain that's pretty rugged these days, and the recovery of dinosaurs is a very slow and arduous process. So we're getting a better and better sense all the time of what's going on in Japan, and it might ultimately turn out to be just as good as the record we're seeing in China or Mongolia. But right now, it's an area that's, of course, mountainous. It's an area that's heavily forested, and the specimens are not being found all that easily. They're there, for sure. Very good specimens there, but it's a slow process and a very expensive process, too.
And I'm sure a lot of them did.
Okay, that's a very interesting
It's
answer. Alright, the next number,
inconceivable to
question
me
number
that
7 is,
something
what
that
do we know of
large
other discoveries of animals that lived in the
actually
same period just
fight
prior
off
to the
the
extinction, but in parts of the world outside of North
like
America?
they did.
Mammals, you said?
Even if they ate
About
each other,
animals,
they had
animals
to sustain
period.
themselves.
Oh, well, we're learning more and more. If we look at just the North American record, for example, say Dinosaur Provincial Park, we have about 40 to 45 species of dinosaurs, but then we have almost 100 species of turtles, and crocodiles, and lizards, and snakes, and fish, and all the other animals that live with the dinosaurs. But none of those specimens, or very few of those specimens, are represented by good skeletal material. They tend to be bits and pieces. And so most of our progress in understanding those animals is based on studying the bits and pieces. For mammals, for example, it's based on looking for teeth. For birds, well, there's some bird teeth, for sure, and isolated bones from different parts of the skeleton, but whole specimens, we just don't have them in North America. Over in Asia, though, of course, you do have bird fossils preserved in abundance in places like Liaoning in China. And a lot of the animals there are not just isolated bones. They're reasonably good skeletons because they were being buried and skeletonized and fossilized under a very different kind of environment that allowed them to be preserved. And so we're learning an unbelievable amount about smaller animals from looking at the beds in northeastern China. But there's got to be other sites like that in the world too, maybe even in North America. And it's just a matter of time before something like that gets discovered. Maybe it'll be a little pocket of sediment somewhere up in a mountain basin down in Arizona or somewhere else. And then we'll find the smaller animals too that are well represented. And we'll move ahead in terms of our understanding. What we do know is that, like a modern ecosystem, large animals like dinosaurs are not the common animals. They're not the most speciose animals. The smaller animals are definitely more speciose. You're always going to find more mice than lions, for example. And it was the same during the Cretaceous. So all the animals that lived with the dinosaurs probably greatly outnumbered the dinosaurs in terms of both species and numbers of individuals. This takes time to find them.
That makes sense. You know, a small little furry mammal is not going to be found as easily as a large dinosaur would be, for just to make a comparison here.
Right. Even if you're looking for it.
Do you think that dinosaur diversity was in decline prior to the KT event?
I'd say that in Alberta we definitely have evidence of that. When you move up the Red Deer River, it's essentially you're essentially moving up through time as well. And if we look at Dinosaur Park, we have anywhere between 40 and 45 species of dinosaurs. If you move up the Red Deer River to Drumheller, the beds are now only about 10 million years before the end of the Cretaceous, whereas Dinosaur Park was probably 15 million years before the end of the Cretaceous, just to simplify it. And we don't have 45 species of dinosaurs. We've probably got about 25 to 30 species of dinosaurs maximum. And we have a greater number of environments that those dinosaurs are actually living in. So dinosaur diversity has definitely dropped off in a 5 million year period here in Alberta. And then as we move to the terminal beds in the Scholar Formation, where we get T-Rex and Ankylosaurus and all those other big dinosaurs from the end of the Cretaceous, here in Alberta we have only about a dozen species maximum. And even if you count all of the species over the western part of North America, you're still only talking about 25 to 30 species. It's way down from what it was in Dinosaur Provincial Park. And, you can argue that, if you look at the Lance Formation or the Hell Creek Formation, that you don't see a great change in those beds in terms of drop in dinosaur diversity, but you definitely see a drop in dinosaur diversity from the earlier Judithian beds into the Lancian beds. I really feel very strongly that the evidence right now strongly says there's a reduction in diversity going on in the western part of North America. Is it going on at the same time everywhere else in the world? We don't know. You know, we just don't have enough late Cretaceous sites that are well enough studied to show us what's going on with the dinosaur diversity. And it might well be that what's happening in western North America is peculiar to western North America because of the fact that the inland seas are withdrawing. We're getting a more continental climate, and as the climate becomes more continental, that means you have warmer summers, colder winters, warmer days, cooler nights. And what that usually does, it correlates very nicely with plant and animal diversity. The more extreme the changes are, the lower the diversity of plants and animals you're going to get. So we can look at the end of the Cretaceous in North America, and we can see that that's going on too. It probably wasn't going on all over the world. So in other parts of the world, maybe there was strong dinosaur diversity right to the end. But I think clearly here in Alberta, we're getting a reduction in diversity.
Well, I've also read, I can't remember the specifics, that there seems to be some indication at the same time that this dinosaur diversity was going down, that the mammals were starting to branch out, maybe even starting to become early ungulates before the KT event.
Including primates.
So,
yeah, there's no question that mammals were diversifying as well. And in fact, birds were diversifying tremendously as well at that time. So they're a little harder to understand because, of course, as I mentioned before, small animals don't get preserved as well or as often or as completely. And so the research on these animals is very, very important to try and establish exactly what's going on at the end of the Cretaceous with both mammals, birds, and, of course, lizards are another example.
Yeah. Snakes too.
Snakes too, yeah, for sure.
Snakes, crocodilians, especially crocodilians, they exploded in diversity throughout the Cenozoic era after the dinosaur extinction.
We're a pretty diverse late Cretaceous fauna of crocs, too, here in Alberta, with different types of alligators in particular.
And could you perhaps tell us a little bit more about the Cretaceous period crocodilians that lived in Canada, leading up to the extinction event?
Well, of course, again, believe it or not, even a croc would be considered a small animal, and they're the ones that we do have full skeletons. We have lots of evidence for teeth and scutes and things like that, and quite a few good skulls and so on. But we have more than a half a dozen different genera and species in the late Cretaceous of Alberta, and these are certainly well represented by parts of skeletons, and even, as I said, a few complete skeletons. But as you approach the Cretaceous tertiary boundary, all our material drops off pretty dramatically. And so by the end, I can't think of a single complete crocodile, certainly not a skeleton, but I can't even think of a skull in the terminal Cretaceous beds in Alberta. We have lots and lots of teeth and scutes and so on, but it's really hard to know exactly what you're looking at from just pieces of skeletons.
Do you have any idea why the Caristodiers were able to squeak through the KT event?
No, I suspect it was just the luck of the draw. I mean, they're pretty cool animals for sure.
Yeah.
And why did they sneak through along with crocodiles? Some people think that it might have had something to do with the fact that they were living in the aquatic environment and consequently managed to avoid the big scale effects of rapid climate change introduced by the asteroid. But it's speculation and only speculation. We just don't know.
All right, the last question from Arson Considered is, in your opinion, when and how did the race of arms and armor begin in the Mesozoic era? Was it the weapon, aka the predator, that gave rise to the armored dinosaurs, or the weapons evolving in response to the armor of the herbivores?
Yeah, of course, these things always go hand in hand, the arms race, whether you're talking about armor versus equipment, like big teeth
Oh,
that
yeah.
would bite through bone
Doing
and
that
so
shit
on.
30,
Or whether you're talking about the hind limbs and how fast an animal can move. Do the carnivores become faster and more aggressive in terms of biting into bone? Or are they responding, in fact, to the fact that the herbivores are, in fact, getting longer legs and becoming faster, and the armored dinosaurs are becoming more heavily armored so that they can hopefully protect themselves against carnivores? Almost certainly, whether it doesn't matter whether one came first and the second was following, both things are influencing each other, and they're co-evolving in that sense. I don't think that it's any different than modern worlds. You can be a porcupine and you can be well protected, you think, by your spines, but then there's always a predator who's willing to push the boundaries of that and go after you no matter what. They don't care about the quills. I actually saw this, a lion take out a porcupine in Africa a few years ago, and the spines of the porcupine were going right through the mouth, through the cheeks of the lion, but it didn't stop that lion from taking the porcupine out and enjoying its meal.
And I've seen pictures of pythons eating porcupines, and unfortunately, it's not ending very well for the snake. It's the quills we see sticking out of the snake's body after it's swallowed the porcupine.
Yeah, exactly. You wonder what the long-term prospects are.
Yeah. And North America, the weasel known as the fisher, uses its intellect to outwit the porcupine in order to make secure a meal out of it.
Mm-hmm.
Making quick bites to the face to gradually weaken it through blood loss, things like that, before it kills it.
Yeah.
Some cats have learned to flip them over on their back to have an easier time of it.
Exactly. So anyway, those kind of armors don't work sometimes, but most of the time they probably do work and ensure the survivability of the herbivore. But there are carnivores that are going to be adapted to taking them out.
And the best example of this would be the Ankylosaurus.
Yeah,
I was trying to think of a question regarding that. Is in your opinion, what would be the best hunting strategy for a Tyrannosaurus if it wanted to make a meal out of an Ankylosaur of some sort, like a Ankylosaurus or so forth?
Well, certainly wouldn't go after the head or the tail. And so it would have to, I think, like armadillos, try and flip it over if you're a bird who wants to eat it, and get at the soft underbelly. The trouble with Ankylosaurs, of course, they're such broad-bodied animals. It'd be really, really hard to flip over an Ankylosaur. Smaller Ankylosaurs, that's a different matter. I think Tyrannosaurs would go after them as a matter of course, and because their armor wouldn't be much protection anyway against the jaws of the Tyrannosaur. But I think as Ankylosaurs got bigger and bigger, then probably they had less problem being preyed on by Tyrannosaurs. We have, of course, a lot of ankylosaurids in this part of the world, and if you think about where they might do some damage to a tyrannosaur with their tail clubs, we have an awful lot of tyrannosaurs with injured fibulae as well, which have re-healed, and it's all the right level to expect it to possibly be from a tail club from an ankylosaur hitting them in the legs.
Well, I probably imagine the T-Rexes that was tangled with the cows were probably desperate. I don't think a Rex would tangle with something so dangerous and so well armored.
Dr. Currie, have you done any work at the Pembina Escarpment over in Manitoba?
No, I've been there quite a few times, and it's an incredibly rich area, at least for marine reptiles and things like Hesperornithiforms and so on. But it's always just a matter of interest going over and seeing the museum and looking at the specimens for me. So they turn up some good dinosaur material. I probably won't spend an awful lot of time there.
Mm-hmm.
Okay, we're just about done with the questions here that people submitted. Alright, this one is from John Daly. This is more on the personal side. Is what got you into studying Tyrannosaurs?
Probably goes back to the Rice Krispies story. That it was the Tyrannosaurus Rex that I wanted more than anything else. And by the end of the promotion, I hadn't got my Tyrannosaurus Rex yet. And so I guess I compensated for that when I moved to Alberta and finally got 2 Tyrannosaurus Rexes in 1 year. And that was the one from the Huxley area, the one from the Crow's Nest Pass in southern Alberta. But no, it's just, tyrannosaurs are pretty cool animals, and the more you study them, the more you realize that these are very, very sophisticated carnivorous dinosaurs. There's an awful lot we can learn from them. And out of all the carnivorous dinosaurs, all the big carnivorous dinosaurs anywhere in the world, the Tyrannosaurs are definitely the best adapted towards taking down big animals. And I'm sure they were incredibly successful at it. And as I was mentioning, their behavior also seems to have been a lot more complex than we thought. They're just cool animals to study. So once I got into Tyrannosaurs, it was really hard to get out of them.
Just a little bit of tea.
That's the same way with me.
Yeah, indeed. I mean, basically, when Tyrannosaurs, when they first started off, they were small, pint-sized. They were living under the dominion of larger, Allosaur and other Carnosaurian-type Theropods. Ones as they got bigger and they got smarter, they eventually pretty much just took out their competition just over time by being smart, by mostly being smarter than the competition. And then eventually they became the top dogs almost everywhere, except in South America, where the Abelisaurs were top dogs after the Crocodilians went bye-bye.
Yeah. But it's kind of funny that, this is the reason I got interested in working in South America is that at the very end of the Cretaceous, we start seeing Hadrosaurs and Chylosaurs and so on showing up in South America. And of course, we see a lot more Sauropods coming into North America. So there is an exchange going on at the end of the Cretaceous. But Tyrannosaurs is not one of the ones that ends up down in South America, at least as far as we know at this stage. We have no confirmed records of Tyrannosaurs. And you got to wonder, why not? If the Hadrosaurs are going there, why not?
Thank you.
And this other question here is, David Church also asked, what was the very first fossil you ever found?
It was actually a cephalopod in Ontario. And I was raised near Toronto, and so along Lake Ontario you just get thousands and thousands of them. And so it would have been a cephalopod, and then a lot of invertebrate fossils initially. I mean, I loved dinosaurs right from the beginning, but basically if I couldn't collect dinosaurs in Ontario, I was going to collect any fossils I could.
Was this Mesozoic stuff or like Silurian or Ordovician?
No, this is Ordovician.
Yeah, okay.
So my first dinosaur was when I moved to, before I moved to Alberta, actually, when I came out to Alberta for my job interview back in 1976. I made sure I did a tour of all of southern Alberta, went to a lot of the dinosaur sites and so on, and found dinosaur bones within minutes of actually getting out of the car. It's a very, very rich area. And the first one I picked up was, in fact, a Hadrosaur tailbone.
That's pretty cool.
What is the story behind the synonym Deinodon for Tyrannosaurus?
Well, basically, Deinodon was described in the same paper as Tyrannosaurus Rex, and also Albertosaurus was described in the same paper as well. And Deinodon was based on the specimen from Tyrannosaurus Rex was based on the specimen from Montana, and Deinodon was based on the specimen from Wyoming. And when it was realized that they were the same animal, then Tyrannosaurus Rex was the proper name for it. The name was seniority.
Thank you.
But only by a couple of pages.
Yeah.
All right, this is the last question that was submitted to me from a group member. Monkey Serena wants to know: is there a possibility that there are larger specimens of Tyrannosaurus Rex that have not yet been found, possibly larger than Sue?
I would say there are, because we do have, at least isolated bones, if not partial skeletons. Scotty, for example, from Saskatchewan, is an absolutely huge animal that in some ways is bigger than Sue. So you start trading off and you start looking at different parts of the skeleton. And, well, Sue's bigger in this bone, and Scotty's bigger in this bone, and so on. And so they're all pretty close to each other in terms of large size, but it doesn't mean that we won't turn up larger ones. There are isolated bones, there are isolated teeth, and so on, suggesting there were larger individuals out there. And Sue was 28 years old, according to Ray Erickson and his studies of the bone, but 28 is not that old. And you can see where there was still room for growth when you look at the bones of these animals, because they had really completely stopped growing. They were still increasing in size slightly. They'd largely plateaued by the time you get to the big guys, but they're still growing somewhat. So I can certainly see that we're going to find bigger, heavier animals, not necessarily that much larger in terms of leg length and so on, but you're always working with the luck of the draw. Chances of finding the biggest human that ever existed are pretty slim if you go onto the streets any day of the week. You may see some big people, but the biggest person is probably somewhere else in the world, and it's going to be the luck of the draw to see that person.
Yeah.
So every dinosaur, we're going to find bigger examples, I'm quite sure.
Now related to that question, what do you think is a probable upper size limit for a Tyrannosaurus Rex? Do you think they could have possibly reached up to 50 feet, possibly as a maximum length?
Well, maybe. I would say the maximum you'll ever see is probably going to be 10% bigger than what we know now. I doubt very much they would ever become bigger than that, just based on what we see in modern animals. But every time you say anything, somebody will come along and find a specimen and prove you're wrong.
We have this all the time with saltwater crocodiles, especially. Many people have come up with accounts of animals that were 25 to 30 feet long, and many of them have not been validated.
Yeah.
The best records indicate a probable decent normal maximum size, like for salties at about 7 meters or 23 feet.
Mm-hmm.
But they could have been bigger a long time, but then hunters like to go out and kill the biggest crocs they find, and their habitats got wiped out. When the big crocs killed, the genes for their large size disappeared with them.
Yeah, exactly. But with the fossil record, of course, you're just finding such an infinitely small part of the fossil record that I think the chances of finding a bigger animal is always going to be good.
And David Hone echoed those same sentiments in his book Tyrannosaur Chronicles.
Mm-hmm.
So I actually am in agreement that there could have been Tyrannosaur specimens in the 14 plus meter range size we just have not quite found yet.
Yeah.
David Hone actually said something in the interview with Dinosaur George, was that because he actually is talking about behavior most of the time, but he actually made a really good point that actually kind of got a light bulb going in my head, was that he said that Tyrannosaurus Rex has long legs for its body size, and for that animal it would actually be a long distance runner. And I would think it might make sense, because these things were built like birds in a way. It's that they have the same respiratory system as birds. They would probably go long distances, but even though they might not, the adults might not be as fast as the juveniles, but they would actually still be long distance locomotive type of animals.
Yeah, and there's no doubt that Tyrannosaurs, all of them, they had pretty long legs, and they could move big distances. And I think that's the reason we find Tyrannosaurs both in North America and Asia, is that they were interchanging between the two continents, and that's because they could move so far. They were capable of walking long distances. And in terms of the speed, well, a lot of people say that T-Rex couldn't have been very fast because once you get up to 5-6 tons, it's really hard to chase anybody down. But their legs are longer than what we see in hadrosaurs, and their legs are longer than what we see in ankylosaurs and ceratopsian dinosaurs. You don't have to be fast; you just have to be faster than what you're chasing.
Exactly. I mean, they're not going to be able to chase down jeeps like in Jurassic Park, but they're still going to be faster than the animals that they're chasing.
Yeah, because that's why cheetahs are the fastest land animals today, is because they're going after antelope, which are pretty much the fastest herbivores in the Serengeti.
That's why pronghorns evolved so fast, because they actually had, once upon a time, a predator that could actually catch them. It was the American cheetah Maracinix trumani. That was the only predator that could have ever catched pronghorns.
Yeah.
That animal died out about the end of the last ice age.
Another question. In your opinion, what are the chances that tyrannosaurs may have eventually lost their arms, as some paleontologists theorize?
This is if they hadn't gone extinct.
Yeah. I would say probably not, because I think Tyrannosaur arms are being reduced just because of the fact that they have a weight balance problem. And, they're essentially giant teeter-totters, and if you put too much weight on one side of the body, then they're going to fall on their face. So Tyrannosaurs had to reduce their body weight as much as they could. But when you look at the arms of a Tyrannosaur, they're still very powerfully built. I mean, just the bone alone is a lot bigger than my upper arm. And Ken Carpenter showed, of course, that they could deadlift at least 700 pounds. They very often show these very robust muscle scars. The scapula itself is very long and suggests that there was a lot of musculature powering those arms. They were being used for something. So although they may be short, they're short because they wanted to reduce the weight on that part of the body. And because they weren't using the arms really as the main way of acquiring food, they were using their jaws, then they basically could shed a lot of the weight by reducing the size of the arms. But the arms still being used. And, maybe it was that they were grappling with prey and they were using these grappling hooks to hold on to the prey while its jaws did their dirty work. Or maybe it was just because when they were having sex, the males needed the arms just to hold on to the females. Who knows? There's a lot of different explanations for it, but it still says the same thing. They were being used. They needed them. They couldn't get rid of them entirely.
Where do you suspect the center of gravity was in a T-Rex?
Just in front of the hips. And there's been some studies done showing that anyway. And that's kind of normal for any of these bipedal animals. They're pretty remarkable skeletons when you look at them, because the vertebrae are all quite short. Basically what they wanted to do is shorten up the vertebral column so it brought the head back closer to the hips. The bones in the front part of the skeleton are very light because they're pneumatic, especially the skull bones. Some of those skull bones are only like about 1 millimeter thick, where you get into the great big pneumatic sinuses inside the skull. It was pretty amazing what these animals were doing to make sure that the front of their body could be counterbalanced by the tail without having to increase the weight and length of the tail.
Yeah, getting back onto the arms of T-Rex, it just, because when I look at Sue's arm, it just seems so robust, and I'm just thinking, like, I would imagine the muscle mass for like the biceps, the triceps, just imagine like how strong these animals were in those arms.
Yeah, I certainly wouldn't want to be caught in one of those arms.
Same here.
Nope, they could. If you try to arm wrestle a T-Rex, you might end up losing your arm in the process.
And the whole body.
course, if they one bite, you're a dead man.
Yeah.
What do you think of Dale Russell's theory of the dinosauroid, of certain species of dinosaurs becoming more intelligent had they not gone extinct?
Well, the Dinosauroid was sort of a thought experiment, and what he wanted to do was point out to people that...
Okay. Alright, guys, we got the lab. We're just about to the finish line here for the recording here. All the main questions have been covered. We're just going to talk about whatever, I guess, for the last 10-15 minutes that Dr. Currie has with us.
I have a quick question. Do you have problems with young Earth creationists in Canada?
They exist, yes. I would say they're not particularly aggressive, which is nice. They do have their own interpretations, and when we go to the Trail Museum, sometimes we see people that are there, and they've created their own guide at the Trail Museum, which is certainly not in line with our labels at the museum. And occasionally I get letters from them and so on, but I would say generally they're a little bit more respectful than some of the ones I've seen coming from your country.
Yeah, I've heard good quote. YouTuber, activist Arnold has repeatedly said that it's only in the United States where these people are taken seriously. They are mocked, ridiculed, and not given hardly much credibility in other more developed countries.
Yeah, it's strange, isn't it?
Yeah, I already had somebody on my podcast who actually tried to actually defy my information, which is actually the first that I've ever had. But I mean, I don't really actually put that into my head. I just usually just ignore it. I have my opinion. He has his opinion. So.
Right.
Yes.
Thankfully, I haven't had too many problems with younger creation, which is good, because I really don't want to get into a fight or an argument with these people.
My policy is if you cause a stint in my group, I just show you the door, kick you by the butt out the door, you're banned, end the story. I don't waste time talking to these people.
Yeah.
Yeah.
The phrase is, don't feed the troll. Don't feed thy troll.
I actually had a in the nonprofit museum that I actually volunteer for. We actually had a conspiracy theorist that actually showed up at the entrance and just went way off. and I was trying not to laugh, but even though I'm just going like, okay, this guy is really out there, it's pretty amazing. Like, some people can actually come up with what they think is real and what's not, But I mean, hey, everybody has an opinion.
Yeah, this is it.
Yes, indeed. I'm just trying to think of a good little. This is more of a personal question regarding Dr. Michael Ryan. How long have you known Dr. Michael Ryan from the Cleveland Museum?
It's actually funny because Michael was in a way my very first student. When I first lived in Alberta, here in Edmonton, he came to one of my evening courses at the University of Alberta. And so I forget what year it was, probably about 1979 or 1980. And once we formed the Terrell Museum of Paleontology, then Michael started working for me during the summer months. Eventually, he went back to school at the University of Calgary, and that's where he took his master's degree and his PhD. So I've known Michael for a long time, 40 years roughly.
That's cool. Yeah.
Come on, there's too much silence there. Say something.
Greg, you alive?
He's frozen.
Oh, hey, now we're on.
Now he's gone. it's a pleasure talking to you, and been an influence in my life, and hopefully continue to actually find more information for us in the field of paleontology. And thank you, and have a nice day.
Well, thank you very much, too. And you have a good day, and hope your technical problems are a little better next time.
Yes, thank you, Dr. Currie. I very much enjoyed talking to you. Thank you.
Well, thank you, too, for your questions.
It was an honor, sir.
Hey, we'll see you.
Lose that.
Take care.
Oh, my God.
Take care.
Bye.